Hello, Gators. Today I wanted to talk about compounds and bonding and then naming of ionic compounds. And as you remember from last week, there's a couple kinds of compounds that we're focusing on. One is ionic. And ionic, remember, is a metal bonding with a nonmetal. And generally the metal is positively charged, and it's sometimes called the cation. And the negatively charged ion, which is referred to as an anion, is usually a nonmetal. Okay, and remember, in ionic compounds, you have a transfer of electrons. So there's a transfer of electrons from the metal to the nonmetal. Now, in covalent, it's generally two nonmetals bonding to each other, and the electrons are shared. So there's no transfer of electrons. The elements just share the electrons. There's also metallic compounds that are basically just electron or metals together, the atoms together, and the electrons are kind of free roaming and delocalized within the metallic matrix. And you can make alloys with metals as well. So that's when you have a mixture of a couple of different types of metals. You'll make an alloy like brass or something like that. Now, ionic and covalent have different properties as well. So ionic compounds tend to make crystalline solids, which have a high melting point, a high boiling point. They conduct electricity well. Most are soluble in water, but not in nonpolar liquids, such as like olive oil or something like that. And again, ionic compounds are metal, non-metal. Covalent compounds share electrons. And again, you'll sometimes find them as gases or liquids or solids, and they're made of molecules. They have a lower melting point, lower boiling point. They don't conduct electricity as well. And many are soluble in nonpolar liquids, but often not as well in water, although that's variable. And again, they're made generally of nonmetals. Now, when we start talking about ionic compounds, it's important to know that there are a variety of different ions. And many of the ions are just single elements, like silver is Ag+, it forms a +1 ion. Other ones are actually a combination of a couple different atoms or a few different elements. So for example, the ammonium ion is NH4+. It's here. Okay, and I think we can use a pointer here too. So yeah, so ammonium is NH4+. And we want you to be familiar with the ions with the little asterisks here. So ammonium is NH4+, silver plus, zinc is 2+, aluminum is 3+. There's also a bunch of negative ions. One of the common ones is acetate, which is C2H3O2 minus. Yeah, and acetic acid is vinegar, basically. There's hypochlorite, which is ClO minus, chlorite, ClO2 minus, chlorate, ClO3 minus, and perchlorate, ClO4 minus. And you'll notice there's kind of a trend there. Cyanide, pretty famous as a poison, is Cn minus. Hydrogen carbonate is more commonly called bicarbonate, which is in baking soda. So baking soda is sodium bicarbonate, and it's HCO3, or yeah, minus. Hydroxide, like sodium hydroxide or something like that, is OH minus. Nitrate, a common compound in fertilizers or ion in fertilizers, is NO3 minus. Nitrite is NO2 minus. Permanganate is MnO4 minus. Some other ones we want you to know are carbonate. Carbonic acid makes caves and stuff like that. CO3, 2 minus. Peroxide, like hydrogen peroxide or something like that, is O2, 2 minus. Sulfate, there are a lot of compounds with sulfates, SO4, 2 minus. And sulfite, excuse me, SO3, 2 minus. Finally, phosphates and phosphites are pretty common. PO4, 3 minus, and PO3, 3 minus. So those are a series of ions that are largely made of multiple atoms. Now, those will combine, you'll generally have a cation in an ionic compound combining with an anion to make a compound. Now, in terms of writing ionic formulas, the charges need to balance out. So the total number of plus charges in a compound has to equal the total number of minus charges. You don't generally write ones as subscripts in formulas. So like you don't write Na1Cl1, it's just NaCl. Always write the plus ion, again called the cation, first, and usually it's a metal. Then you write the negative ion or anion, which usually is a nonmetal. So there's a few steps for writing ionic compounds. And first off, we're going to talk about the formula. When you want to go about doing that, I would first off assign each element or group the charge that that element or group has. So for example, magnesium is 2 plus. It's in the second column. It's an alkaline earth metal. Aluminum is in the third column. It's P1 basically. So Al3 plus. Fluorine is a halogen, F minus. And again, from that sheet we just talked about, OH minus and PO4 3 minus phosphate are some examples of ions with charges. Now look at what's being combined. Are the charges opposite? Do they automatically balance? So if they automatically balance, you can just stick them together. So for example, Sr2 plus and Te 2 minus just go together to form Srte. If the charges don't balance though, you have to have enough of each ion to make the overall charge balancing. So for example, rubidium has a 1 plus charge. Sulfur, the sulfide ion, is -2. So 2 rubidiums would be needed to make +2 charge. The S, again, we said has a 2 minus charge. So if you have 2 rubidiums, 2 times the 1 is +2. 1 sulfur is -2 charge. Again, then you have a +2 and a -2. They balance out. So your formula of rubidium with sulfide ion would be Rb2S. Now, again, make sure that you balance the charges to be 0. So here's some examples. So if you have Na plus, Cl minus, the charges balance, so you have NaCl. If you have Mg2 plus, O2 minus, they balance, so MgO. Na plus, OH minus, they balance, NaOH. Here though, you have to actually turn things around a little bit. So magnesium is +2, bromine, the bromide ion, is minus, so you need 2 of these to get -2 to balance out the +2. So you have MgBr2. Ca is +2, NO3 is minus, so again, you have a 2 here, so you're going to need 2 there. Now to show 2 of this whole group, you use parentheses. So it would be Ca in parentheses, NO3, 2. And that's kind of like in math, where the 2 refers to everything inside these parentheses here. Lastly, lithium and PO3 minus 3 goes to make Li3, PO3. Now, if you want to name, kind of going the other way, first off, identify the ion. If it's binary, you name the positive ion first, then put the negative ion in and end it with "ide." So for example, NaCl is sodium chloride. If it's polyatomic, meaning it has a group, like the sulfate or something like that, use the group name. So you'd start with the metal, Na, and then you have the group. This is the chlorate ion, so it's sodium chlorate. Now, transition metals, we've said, have multiple possible charges. Because of that, use Roman numerals to tell the charge. And you can kind of reverse balance if you need to. Now, some elements don't have different charges, even though they are in that area of transition metals. For example, silver is always 1, zinc is always +2. If you want to practice ions, there is a little Quizlet there. Now, just some examples of naming. So MgCl2 is magnesium, and then chlorine, but we said it ends in "ide," so magnesium chloride. A polyatomic example, we have sodium here, and then it helps to recognize the ion. This is the acetate ion, so it's sodium acetate. With the transition metal, again, you have to look at what you have here. We have iron, and we have the chloride iron, so it's iron chloride, but because iron is a transition metal, we need to look at what the charge is on the Fe. So chloride has a -1 charge. It's a halogen. So there are three of them. 3 times -1 is -3. That means iron needs to be 3 plus to balance out the 3 chloride ions. So we have iron 3 chloride. Now, sometimes it gets a little funky here because like here we have Pb, or lead, 3, PO4, 2. And so this is phosphate. Phosphate has a 3 minus charge to it. There's 2 of them, so that's 6 total negatives. Since there are 3 leads, each one has to have a negative or a +2 charge. Because +2 times 3 is +6, -3 times 2 is -6, and it would balance out. So since each lead has to be a 2 plus charge, we then have lead 2 phosphate. So recap the process. Name the formula. First off, write down the cation, then the anion. Assign a charge to each. If it's balanced, then you're good. If not, you can kind of swap and drop the charges. So write the final compound without any charges, since they should cancel out. Now going formula to name, first off identify the cation and then the anion in the compound. Write the cation first, then write the anion. For a group, just write the name of the group. For a binary compound, write the anion ending with "ide." So then I have some practice here, and you can work on the practice. So that was just a brief introduction to naming.